Now let us consider the method of complementing a DFA. Just now we have seen that if the languages are complemented, we can complement the DFA and then accept the other language too, right? So this method, whatever I am going to teach now, is going to apply only for DFAs. Always keep in mind, complementing a finite automata works only for DFA, not for NFAs. Okay, so let's take a small example and let me explain you this. Let us say I want to accept set of all strings of even length strings over a comma b. 0 length I have to accept it, 1 length I should not accept, 2 length I should accept, 0, 1, 2, 3, 4, 5, 6, 7, right? And if I have to accept odd length strings, then it is going to be 0 length I should not accept it, 1 length I'll accept, 2 length I will not accept. Just compare these two diagrams. Both are looking exactly the same. It is, see, two states and then transitions are same. Only difference is the non-final states are made final here and the final states here are made non-final here. Okay, and even you can take a bigger example and see, right? So let us call this one as L1 and this one as L2. Then we can say that L1 is complement of L2. L1 is complement of L2. Alright, let us take one more bigger example. Set of all strings starting with A. Starting with A. Okay, so if a string is going to start with A, if a string is going to start with A, I am going to accept it. If it is going to start with B, I am going to reject it. So this is the final state, right? Now starting with B. So if a string is going to start with B, or I will say set of all strings not starting with A. So what could be the language? Language even contains epsilon because epsilon does not start with A, and language contains B, and language contains anything that starts with B, so on, right? Therefore language contains epsilon plus anything that starts with B, which means initial state has to be final state, and anything that starts with B should be accepted, A comma B, and if anything starts with A, it should not be accepted. Just compare these two diagrams. If this one is L1, this one is exactly complement of it, and you see the DFAs. This one is starting with A, this one is not starting with A. This one is even length string, this one is odd length string. So if you look at these diagrams, you can understand that in order to complement a finite automata or in order to complement a language, you can construct the DFA for one language and you can complement the DFA and you can get the DFA for the complemented language. Especially if you make all set of non-final states as final and final states as non-final, this is nothing but the DFA which we wanted. Okay, so now let us define what is complementation. If complementation of a DFA is nothing but, okay, first point number one is this complementation applies only for DFAs, not for NFAs. That is point number one. Complementation method, which is nothing but converting non-final states to final states and final state to non-final state. It is applied only for DFAs and not for NFAs. Point number 2 is, in order to get a complement, let us say one finite automata is, one DFA is Q sigma delta Q naught capital F, where F is the final states, set of final states. If I have to complement it, if I have to complement the DFA, leave the states as it is, leave the input as it is, leave the delta as it is and initial state as it is, but just take the complement of final states, which means initially whatever were final state, they should become non-final. So this is the complement DFA, complement of DFA. So from these examples it should be clear that, let us give them some names: A, B, A, B, A, B, C, A, B, C, right? From this example it is clear that here Q equal to, set of states equal to capital A comma capital B, and final state equal to capital A, and here the final state equal to whatever is the Q minus A, which is nothing but B, right? And here the set of states Q equal to A, B, C, and the final state F equal to, set of final states F equal to B, and now the final states here equal to Q minus F, so which is nothing but, from all possible states you have to remove B, which means A and C is the final state. Everything else remains same. See this, everything else remains same. If I am going to complement a DFA, first of all this method applies only for DFA, you should not complement a NFA. First of all, this method applies only for DFA. Secondly, if you are complementing a DFA, everything has to be same. Q has to be Q, sigma has to be sigma, delta F, everything has to be same. Only changes, final states will be made non-final states and vice versa.